Good morning. So, what is the next big thing in computers? Well, I think I've mentioned it before. There really isn't anything. Nothing really new on the horizon for the commercial side or for the consumer side. Um, when you get into university grade computers and stuff like that, they talk about quantum computers, but those are not going to be available for everyday users. Probably never, to be honest. So we're kind of stuck with the computers we've got for now. There was talk of optical computers at one time, but that kind of died. Um, and so they started talking about quantum computers. Now, if you're not sure what a quantum computer is, this is the optical ones. But if you're not sure about what a quantum computer is, it's the idea, and it gets into a lot of science. It's the idea of taking a particle like an electron. Gotta go. So I'm back. I started this video yesterday and I got interrupted that with an emergency service call and I was out for many, many hours. So I didn't get back to this until today. Um, so anyways, back to what was a particle or what was a quantum computer. A quantum computer is using a particle, either an electron, a photon, something of that nature. It's really, really small. We can't see it. But it takes into account the probabilities. Like I said, there's a whole lot of science and physics in it, and if you really want to know how it works, there are tons of YouTube videos out there that kind of explain it. They call them qubits. Not the game, if you remember the game. Nope. But they call it qubits, and I think the biggest one right now is 40 qubits as a processor. The idea is you feed it full of information, and it takes track of spin, and yeah, I think it just takes care of spin. I think that's what it was. I'd have to look at it. Anyways, the idea is behind it, you feed it full of information. Because you're not, this is where that whole thing in science comes in, that you don't know what the results are until you observe it. So you feed full of information, but you don't look at it. And then you look at it, and then it gives you the results. And for the most part, they've been pretty accurate. However, if you understand a little bit of physics and this whole thing of how the world of the very small works, you can understand that there is going to be a problem with this in the future, because it works on probabilities. It's observing a wave, and then when you observe it, the wave collapses down, and it's supposed to narrow in on reality and what the correct answer is. But you're still dealing with probabilities. And like I said, for what they've done for theoretical work so far, it works well. However, if I asked a quantum computer what is 1 plus 1, I would say the vast majority of the time it's going to give me the answer of 2. However, there is the possibility, because of how quantum works, it'll give me 3, negative 1, 12. Because that's just how the world of small really, really works. This is why I don't see quantum computers myself. I don't ever see quantum computers sitting on your desk. It's not going to work. Especially in a business setting where you need to, or you're doing budgeting, or you're doing balancing your checkbook, and you need the accuracy. Yeah, the vast majority of the time, a quantum computer will give you the correct answer, but there is the possibility of it giving you wrong answers, and that to me is just not acceptable. Like I said, in the realm of theoretical physics and expanding science through probabilities and stuff like that, where we're still developing and learning, where it's still theory, not necessarily law, fine, use the quantum computers. But you, me, yeah, you know what I'm saying. You, me, having a quantum computer sitting on our desk, I don't see that happening anytime ever. So this goes back to then what's the next big step in computers? Again, as I previously said in the beginning of the video, there is nothing. They're going to be adding more cores to processors. We might start seeing the reinvention of multiple processors. They still do exist. They're just more business application and corporate applications, but you don't really see them in individual computers. But they do still exist. And it's old tech, but it's coming back. So yeah, you can get multiple processors on a motherboard. And as you can see, that yeah, that's kind of expensive. So they still make them. They're just really, really up there in price. Just look at this one. This is two processors, and you could probably put. I'm not sure which processor goes in this one, but if it was a Threadripper currently makes a 24 core processor, so that would be the equivalent of 48, and then you add the threads to it, that brings it up to 96 or more. And so, yeah, could I see that type of a computer on your desk? I really even think that's too strong and too powerful. I mean, this is really designed for server applications. Certainly, you can put it on your desk if you got that type of money. But yeah, I just don't see anything more than an 8-core processor on anyone's desk anytime soon. Of course, I'm sitting here recording this on a 16-core processor, so yeah. Yeah, the number of processors or number of cores on processors are going to go up. The amount of RAM computers can take is going to go up. I think this one I've got on my desk now can take 128 gigabytes. That's a whole heck of a lot of RAM, but I would use it too. Hard drive technology, we're going down from, physical hard drives down to solid state hard drives that are about this big. So computers, the components will get more but smaller. That's just Moore's law. Every 2 years, or well, originally Moore's law was every 18 months. Now it's like every 24 to 36 months. A computer processing power doubles. But I think they're even saying now, I've seen research where they said they think that they were hitting the limits of Moore's law simply because you can't make the chips any smaller. I think AMD has got a processor out there right now that they're either coming out with or it's still in development, where the processor lines are literally 7 atoms wide. Okay, and I know that's kind of hard to imagine, but it's so small that even your hair is too big. And then even when you get that small, then you have to worry about other things like cross-contamination and signals jumping from one line to another, and it gets into a whole lot of problems. So yeah, I think until there is a major breakthrough in computers, we're pretty much at the limit that we can go, at least for consumers. Again, business side, they do a whole different thing. You get into multiple processors, multiple cores. But those are server sides. I think what's going to happen is that, like I said, with the exception of gamers and business, I think desktops are going to go away through the course of the next 30 years, and tablets are going to be the way to go, and those are going to pick up in power and speed, simply because they'll learn to do better cooling, and that's the big drawback for tablets right now, is keeping them cool. This monster here on my desk has a liquid cooled system in it. I thought I would never have to put a radiator in my computer, but I've got one. It's kind of like the radiator in your car. Yep, does the same thing. So eventually they'll figure out how to keep the tablets cool, and they'll get bigger and stronger and faster that way. But yeah, I don't see anything on the horizon that is going to be a fundamental game changer in the world of computers anytime soon. So, like I said, quantum computers, you will never see one. You might see one if you go and visit a school or a university. It's a possibility that governments may have them, but you and I will never have a quantum computer. There's no justification for it because they're not always accurate. Despite what the physics says, there is the probability that 1 plus 1 equals 3 in the world of a computer, quantum computer. So, and you and I know that's not the case. So, yeah, nothing really big or amazing on the horizon anytime soon. So, it is what it is. So, with that, I'm going to let you all have your day. If you found this useful, like, share, subscribe. You know the routine. It's down this way, thumbs up this way. Share it with your families and friends and pass it around. If you've got your Google account or a YouTube account, you can certainly subscribe. If you don't, you can find us on Facebook. In the video description before, click that see more. You can see the rest of the information on the video. Computer problems, give us a call. We can fix the good old classic computers. No one bring me a quantum computer. I would have no clue. So, but if you got computer problems, give us a call. There's our address. If you're in our service area, we can come to you, or you can schedule a time to drop it off with us. You guys have a great day. I'll talk to you later.